Hello, greetings again from Berkshire Guitar Amplifier Repairs at Reading, England. Stuart Smith, as usual, to give you the pleasure of looking at a Fender HotRod DeLuxe Mark III. Now the customer says that this amplifier makes a horribly loud hum, so I think let's just not mess around and turn it on and see if we agree with him. Right, I've got it plugged in. Standby on. Yep, the dual light's on. It all looks fairly clean. Apparently it's only 5 years old. It's gone out of warranty and then immediately failed, so that's not good. Right, let's turn it out of standby. Okay, I can hear that immediately. I would call that a horrible loud hum. Right, so I'm not going to mess around. I'm going to get the back off and have a look inside. I have an immediate suspicion, question mark, and that is over the smoothing, HT smoothing caps. But let's not jump the gun. Let's take the back off and see what we can see. Okay, back is off the amp and we're going to have a little look around inside. The immediate suspect here are these HT smoothing caps. Now, I would have thought they would be okay. They're only 5 years old and wouldn't expect those to be going at this stage. Another suspect are these, see how these resistors here, again Fender are still doing this, putting these resistors down onto the board, getting very hot, and I've had these very loose. These don't actually feel loose, just waggling them. And also these capacitors can come loose. See, they are a little bit loose, those. Not good, that. It's got some hot melt glue between them, but it hasn't got any hot melt glue going down to the board, which is what it needs as an anchorage. Right, so the other thing I'm going to look at, let's have a look at the valves. Now, see, that's interesting. I don't know if you can see that. The valves are quite hot. What I mean is, of course, they've got quite hot in the past because the printing has burned off them. So we're going to need to check both of these valves are okay and also check the bias at some point too. So if you have a hum on an amp like this, always suspect these capacitors first of all. And if you have a little look underneath the positive side, you should be able to see if there's any leakage coming out of the capacitors, any kind of gunk. Any gunk means the capacitor is definitely no good. And I don't see any gunk coming out of these, so it may be that they're okay. But anyway, I'll show you what I'm going to do. Very quick test for capacitors. I'll get it set up and I'll show you what I do to quickly check that these caps are okay or not. Avid channel watchers will have seen this gizmo before. I've just made it up in a die-cast box. It's got a 100 microfarad 450 volt capacitor inside here across these clips here, across this probe, which means I can kind of dab on another capacitor across an existing one. Then I also have the ability to discharge the internal capacitor by pressing that, or I can clip this onto a capacitor and with the amp off, discharge the HT caps so that the amp is safe to work on. So let's just check the status of this amp in terms of safety. Yes, it's plugged in but switched off. So I'm going to go ahead now and just, I think I'll just start with this biggest one here. 500 volts and 47 microfarads. I'm going to clip this to the negative. I'm going to turn the amp on, and I'm just going to dab this onto the positive. You get a little bit of a spark as this capacitor charges up quickly. But that's effectively putting a 100 microfarad capacitor straight across there in parallel. Let's turn it on. And if that capacitor is faulty, the hum will just go away the second I touch this probe on. I can hear the hum starting to build up now. There it is. Horrible nasty hum. Right, let's go ahead and put this across. Ooh! Whoa! Well, well, well! Huh, got it in one look. Horrible hum. Stick a capacitor across. Hum gone. Well, don't normally go that quickly, that well. I'm just going to discharge this now because I've got on the end of this probe, I've got, you know, 300 volts or something. I do have an internal discharge resistor as well to this box, but it takes a little bit of a while That's just in case I forget. So I'm just going to press my green button on here for 10 seconds, and there's a 10k internal capacitor which just internal resistor which just discharges that capacitor. So there we go. So I should now be able to touch these together and not get any spark or anything, which I don't. So that's good. Right, so we need to change that capacitor. And that's the question now: do we change them all? Let's turn that off. Do we change them all at this stage, or do we just do the faulty one? The reason I'm hesitant is because the customer is a little bit price sensitive, so you may not want all that done. So just a quick word about this. It's a 5-year-old mint condition amp really, and it's failed after 5 years, and that's because Fender have put in crap capacitors. These IC capacitors are absolute rubbish. So it's shocking really, you know, a company like Fender, they know they're rubbish. They're 11.5 pence cheaper than a decent one, or whatever the hell it is, and they just put them in anyway. So I really utterly despair sometimes, but anyway, there you go. That's what goes on these days. So I'm going to call the customer and ask them how much they want to spend really. Just put one cap in there, or do all 4. And whilst I'm waiting to hear from the customer, I'm going to go ahead and change this capacitor anyway, and I'm going to put in a decent F&T 47 microfarad at 500 volts, proper capacitor. And I know some people will shout at me, but I do this from the top side of the board just by kind of literally cutting out the old capacitor. Like that. And nothing obvious, by the way, on this look. No obvious leakage or anything, that's just failed. And I put the new capacitor in from the top here. It saves money, and all my customers are money sensitive. The difference between a £50 repair and an £85 repair is quite significant. It's perfectly good enough, the fix I do here, and it saves taking the board out, which is very difficult. And when you take the board out, you stress these ribbon cable connectors here. They get flexed and bent, and you can cause more problems than you save. So I've just taken a view over the years to do it from the top side, like this, and not take the board out if I don't have to. So I've got a little glue, hot melt glue gun here, so I'm just going to run some hot melt glue down onto there to hold that in place. Always put the legend facing out so that the next person here can see what's going on. That glue didn't, that's interesting, that glue didn't glue on that. Who doesn't like that silicone? That's silicone there. I think I'll try and take a bit of that off. Yes, I scraped the silicone off, and the hot melt glue took without any problem. Would you believe that didn't stick again? I don't know whether that board is ultra smooth or something, or maybe it's got a kind of silicone, you know, coating over it now after that silicone sealant. So I'm just going to use a little double-sided pad, which will do the job. Stick this onto here like this. And stick the capacitor onto the pad. Like so. Yep, hooray. That's done. And now I'm just going to bend these wires around the ends here. Right, I'm going to tidy that up a little bit with my finer nose pliers before I solder it. Right, there's the capacitor in, and it's the right way round. Positive is down, negative is up. That's good. I think we'll go ahead and turn on. Okay, that's switched on and out of standby. And it's not working. I don't know why it's not working, but what do you think these things are I found lying around on the bench? Do you think they kind of go in there somewhere? I don't know. I'll see if I can jam them in somewhere. Right, might work a bit better with those in. Out of standby. No hum, so that's good. Oh yeah, lovely. Nice. Drive channel. More drive. Clean channel. Great, well, that's just one capacitor, of course. I'm just going to wait to hear from the customer. Well, that was an amazingly good fix, I think. Just went straight to it. The valves have been getting hot. I'm going to put them on a bias meter in a minute, see what they're doing. They were both okay though. I measured them on the machine and they were both reasonably matched, not fantastically matched, but good enough. And as long as the bias isn't too crazy on this, I think we're going to call that job done. Nice one. I've put my Eurotube's bias meter in on this valve here. Look, here it is, and it's all on, and it's not terribly easy to read this one. I'm going to have to read it for you maybe, but it's saying 440 plate volts and 24 milliamps, which is actually quite low. So I'm just going to check what the correct bias current should be for this. I would guess more like 35 milliamps, and then we'll bias this amp up properly. These valves could have got hot a long time ago. We don't know anything about the history of these valves. I like this bias calculator from Weber, tedweber.com. So select the valve type, and in this case it's 6L6 there, and the plate voltage is 440. I'm trying to do this left-handed whilst holding the camera with my right. 440, and calculate bias. And as expected, it should be higher, so it's 47 milliamps it should be. So I'm going to tweak up the bias on this using this pot here. So we're going to be monitoring this down here, and I'm just going to turn this, I would imagine it's clockwise for increased bias current. Yes it is, so I'm going to turn this up till I get about, I'm going to bias it a little bit cooler than they say. Yeah, 40 milliamps is fine. I'm going to leave it at that actually. I don't like biasing these amps too hot, and these valves have got hot in the past at some point, so it's going to bias slightly on the cool side. So there we go, that's job done. Well, I wish they were all that simple. Very straightforward repair, and the customer didn't want me to do the other 3 capacitors, which would have been a fair bit more money, because they're not very cheap, those capacitors. They're £7 or £8 each for a decent cap. So job done on that one, and I hope that has helped you in case you get hum on your Fender. That's the first thing to look for. HT smoothing caps is the #1 culprit. Well, thanks as always for watching. I'll catch you on the next video.